Welcome to another episode of Terry's Notes, and today we are going to be looking at speed, velocity, and acceleration. Okay, so the first thing we need to do is to understand the difference between distance and displacement. Now, distance is a scalar quantity, whereas displacement is a vector quantity. Displacement is the distance moved in a stated direction. Now, a very simple diagram can easily explain the difference between distance and displacement. Suppose we have a man, he starts at point A, and he is taking a walk through a park, and he goes along this path here. So he's walking, and he ends up at the point B. The total distance traveled by the man will be represented by this line here. That will give us the distance traveled by the man. But this arrow joining the point A, it's point A, and point B represents the displacement of the man. Okay, so if we notice, you recall that a vector has magnitude and direction, and it's usually represented by an arrow. The length of the arrow represents the magnitude, and the direction of the arrow represents the direction of the vector. So this is distance travel, and this represents displacement. So it is possible for someone to move through a particular distance and their displacement could be zero. Let's say somebody starts at this point here and they travel along a path and they come back to the same point. They would have covered some distance, but their displacement is zero because they ended up coming back to the same point. Now let's look at the difference between speed and velocity. Now, speed is the rate of change of distance with respect to time, and speed is measured in meters per second, and speed is a scalar quantity. The formula to determine speed is distance divided by time. Now you need to recall the definition for speed, so make sure you learn this definition as it is here. Velocity, on the other hand, is the rate of change of displacement with time. So we just looked at the difference between distance travel and displacement. So velocity is the rate of change of displacement with respect to time. It is also measured in meters per second, and it is a vector quantity. An arrow can be used to represent velocity, right? Because we know that an arrow has, we can represent a vector using an arrow because the length of the arrow represents the magnitude, and the direction of the arrow represents the direction of the vector. Now, velocity is given by distance over time as well, but this D really represents displacement. Okay? Acceleration is the rate of change of velocity with respect to time. So you need to learn this definition. And acceleration is measured in meters per second squared. And it is also a vector quantity, because if we look at the definition, it is the rate of change of velocity. And velocity, we know, is a vector quantity. Now you need to recall this formula for acceleration. It is equal to v minus u over t, where v is the final velocity, u is the initial velocity, and t is the time for the velocity to change, right? And you will also see in some books they will write it as v is equal to u plus a t. Whichever one you remember is fine, right? But I usually teach this one because it gives you an idea, or it allows you to remember the definition for acceleration. Because final velocity minus initial velocity is really change in velocity. So acceleration is the rate of change of velocity over time. Now let us look at an example. A car starts from rest and travels at a constant speed of 10 meters per second for a period of 12 seconds. Calculate the distance traveled by the car. Now, if we extract the information from the question, we know that the car is traveling at a constant speed of 10 meters per second. So therefore, the speed is equal to 10, and the length of time we are looking at is 12 seconds. So t is equal to 12. Now we want to determine the distance traveled by the car. Now speed is distance over time, therefore distance will be equal to speed multiplied by time. So distance in this case will be equal to 10, which was the speed, multiplied by 12, which was the time, and this gives us 120 meters. Now let us look at another example. A car is traveling at a velocity of 10 meters per second. Its velocity increases to 15 meters per second in a time of 20 seconds. Calculate the acceleration of the car. Now we know that acceleration is equal to final velocity minus initial velocity over time. So the car was originally traveling at a velocity of 10 meters per second. So therefore u, which is initial, is 10 meters per second. The velocity increases to 15, so therefore v is equal to 15, and t is equal to 20, because it took 20 seconds for this change to occur. So if we just substitute into the formula for acceleration, it becomes 15 minus 10 divided by 20, which gives us 0.25 meters per second squared. Now you just need to stick with one unit, so we can use this notation, or we can use this notation. The one I prefer to use is this one, right? But for completeness sake, I'm showing you the both units because they both mean the same thing. Now, the motion of an object moving in a straight line can be represented graphically. So this type of graph here is known as a distance time graph. In this case, we have distance on the vertical axis and we have time on the horizontal axis. Okay, so these are just two examples of distance time graphs. Now these types of graphs are very useful. So there are several pieces of information we can gather from a distance time graph. First thing is that we can use the distance time graph to determine distance traveled, right? Because if we look directly from the graph, we have distance against time. So therefore, at any point in time, we can determine the distance traveled by the object. We can also determine the speed from a distance time graph. The speed can be found using the gradient or the slope of a particular segment of the graph, right? So let's say we have this distance time graph here. In this first section here, let's call it 0, and let's call this first section, let's say up to T1, and the second section here is up to say T2. Between 0 and T1 we have a straight line, and we know that this line has a positive gradient, and we also know that the slope is constant because it is a straight line. So if the slope is constant, it means that the speed is also constant, right? Because the slope of a distance time graph is really speed. Now if we look between T1 and T2, the line is horizontal. Now the gradient of a horizontal line is 0, which means that the speed between T1 and T2 will also be 0, right? So in a situation like this, we might have an object starting at a particular point and it is moving at a constant speed, and then it probably stops, right? Because we notice that the distance isn't increasing after t1, right? Now let's look at velocity time graphs now. Now from a velocity time graph, you can determine several pieces of information about the motion of an object. The first thing we can determine is the distance traveled by an object. So let's say we have a velocity time graph here. So we have velocity on the vertical axis and we have time on the horizontal axis. Now if we want to determine the total distance traveled by this object, all we need to do is to find the total area under the graph, and this will give us the total distance traveled, right? So in this case, if we look at this graph here, the shape that we have is a trapezium, so we can find the area for trapezium very easily. We can do it in two ways, by just using the formula for the area for trapezium, or we could break up the shape into two triangles and a rectangle. So we have one triangle here, we have a rectangle here, and we have another triangle here. So the distance traveled can be found by finding the area under the graph. We can also find the speed at, or the velocity at any point in time, right? By simply reading off the value of the time on the graph. And the third thing we can find is the acceleration or deceleration by finding the slope. So this is a velocity time graph. So we can find the acceleration or deceleration at any point in time by simply finding the slope. So let's break up this graph again. So we have 0, let's call this t1, t2, and t3. So between 0 and t1, we notice that we have a straight line. Therefore, we have a constant gradient. So because we have a constant gradient here, we're going to have a constant acceleration. Between t1 and t2, we have a horizontal line. The slope of a horizontal line is 0, which means that the acceleration between t1 and t2 will be 0. If your acceleration is 0, it means that you have constant velocity. Got it? Now between t2 and t3, we notice that we have a straight line, therefore the slope is constant. However, the gradient is negative. Now when we have a negative gradient, it means that the object is slowing down. Therefore the object has a constant deceleration, or if we do the maths, we will get a negative acceleration. Okay? So let us do an example. So we have a girl of mass 50 kg starts running along a straight level road and stops after 70 seconds. The variation of her speed with time is shown in figure 5 below. Okay, so we have speed on the vertical axis and we have time on the horizontal axis. So we want to calculate the total distance the girl runs. Now from what we just learned, we know that to calculate the total distance traveled from a speed time graph or a velocity time graph is simply the area under the entire graph, right? So the total distance traveled will simply be the area under the graph, which is the area of the trapezium. Now, the area of a trapezium is given by A is equal to a half the sum of the parallel sides multiplied by the height, which is equal to a half. Now the parallel sides here, in this case, one will be from here to here, which is 70, plus and the distance between here and here will be 60 minus 20, which is 40, multiplied by height, and the height in this case would be here, which is equal to 6. And if we work out that area, we're going to get 330 meters. Right? So I have the work in here. It's 330 meters. Now the second part of the question asks, what is acceleration in the first 20 seconds? Now in order to determine acceleration from a speed time graph or a velocity time graph, we need to find the slope. So we're looking at the first 20 seconds, right? So we want to get the slope of this line here, right? So acceleration is simply v minus u over t. In this case, your final velocity is, or speed is 6, initial was 0, and your time is 20 seconds, right? Again, I have worked this out here. So it's 6 minus 0 over 20, which gives us 0.3 meters per second squared, right? And the last part of the question asks for what is the magnitude of the force that produces this acceleration. Okay, now once we are asked to find magnitude of force, we're going to be using the formula F is equal to ma, because a force is required to produce an acceleration. And we know the mass of the girl is 50, and the acceleration we are referring to is the one we worked out in part 2, which was 0.3. So this is 0.3, and this gives us 15 newtons. Right? So whenever we are asked to find a force that was required to produce an acceleration, we use F equal ma, and that is straight from Newton's second law of motion. Let's look at another example. Explain the meaning of the following terms and state the SI unit in which each is measured. Okay, so constant speed. So speed is simply the rate of change of distance, and when we say constant speed, it means that the speed is not changing, and the SI unit is meters per second, or it can be written as m//s. And acceleration is the rate of change of velocity with respect to time, and the unit for acceleration is meters per second squared, or we can write that as ms squared, right? So let's look at the calculation now. The graph represents the motion of a cruise ship after its engines have been turned off. So what type of graph is this? If we look, we see we have speed in meters per second, and we have time in seconds. So the first part of the question asks to calculate the deceleration of the ship. So the deceleration is simply the slope of this line. Alright, so okay, so I had the definitions here. Constant speed is speed that does not change with time. Acceleration is the rate of change of speed with respect to time. Well, this should really be velocity. Alright, okay, so deceleration of the ship is simply the slope of the line, and we will use v minus u over t, in which case if we go back to the graph, your initial speed u is equal to 10, because I can read this off right here, and your final velocity or final speed is 0. So v is 0, and the time taken to do that is 1800 seconds. Right, so t is equal to 1800. So if we work out the deceleration, it will be 10 minus 0 over 1800. And you might say, well, you said u is 10 and v is 0. But in the formula, I used 10 minus 0. Now, if we had used the formula A equal V minus U over T, we would have gotten 0 minus 10 over 1800, which would give us minus 5.6 by 10 to the minus 3. So we would have gotten a negative acceleration, which is really a deceleration. Okay, so whenever you're asked to give or to determine the deceleration, you just put a positive value. So the final answer is 5.6 by 10 to the minus 3. Now the second part asks to calculate the distance the ship travels while decelerating. So we have a speed time graph. So therefore we can determine the distance traveled by finding the area under the graph. Now if you look at the graph, this shape is simply a triangle. So we can find the area under the triangle here, and that will give us a half base by height, which is a half multiplied by 1800 seconds multiplied by 10, which gives us 9,000 meters. Okay. Now, third part says if the ship has a mass of 2.5 by 10^7 kg, calculate the magnitude of the force acting on the ship during the deceleration. Again, once we are dealing with acceleration and we are asked to determine force, we're going to use F equal ma. Okay, so F equal ma, and like I said, this is from Newton's second law of motion. So they give us the mass of the ship, which is 2.5 by 10^7, and the acceleration is what we just worked out, right? And this gives us 1.4 by 10⁵ newtons, right? And the fourth part of the question asks, what is the nature of the force acting on a ship which leads to the deceleration, and how does this cause the ship to slow down? Well, this force here that we worked out really has a negative sign in front of it, right? Because if we had worked out the acceleration, we would have gotten minus 5.6 by 10⁻3. And the force in this case is resistive in nature. The drag force between the ship and the water acts in the opposite direction to the motion of the ship and causes it to stop. So therefore, a force is required to cause the ship to stop, and it is acting in the opposite direction to which the ship is moving. Okay, so just to recap, you need to recall your definitions for speed, velocity, and acceleration. And you need to remember the type of information you can determine from a distance time graph and from a speed time graph.